Long before we had computers, there was a machine that, in a way, learned to think using thread. In this explainer, we're going to dive into this absolutely revolutionary 19th century invention that used a kind of binary code to weave these impossibly complex images. It really laid the groundwork for our entire digital world. I mean, just look at this fabric. The detail, that repeating floral pattern, is just beautiful. It looks like a work of art, right? But what if I told you this wasn't made by some master artisan's hand, but by a machine? And not some fancy modern machine either, but a device that was invented way, way back in 1804. So that's the big question, isn't it? How on earth do you program a purely mechanical device to create images with this kind of detail? Well, the answer is a story of pure genius, automation, and what you might even call the world's very first pixel. Okay, so to really get why this was such a breakthrough, we first have to understand the problem it was trying to solve. Before the Jacquard loom came along, making intricate patterns was just incredibly slow and super difficult. You were really limited by the technology of the day. This table here really lays it all out. See, earlier looms like the Tappet and Dobby systems, they were pretty limited. They could only control a small number of thread groups at a time, maybe 48 tops. Now, that's fine if you're making simple stripes or plaids, but for these really complex, beautiful images, you need to be able to control every single thread all on its own. And that, right there, is where you see the breakthrough. Just look at the Jacquard column. No limitation. That was an absolute game changer. So the big question is, how did Joseph Marie Jacquard pull this off? Well, he introduced a concept that would, believe it or not, echo through the next 2 centuries of technology, a program. And this was his programming language. I know, it might not look like much. It's just a piece of cardboard with some holes punched in it. But every single one of these simple cards holds a line of mechanical code, a set of instructions that the loom can read and execute perfectly, over and over again. So here's the key. Each card controls just one single pass of the shuttle, which weaves one horizontal row of the final image. You'd actually string thousands of these cards together into a long chain to create the whole program for a tapestry. Every single hole, or the lack of a hole, it acts like a single mechanical pixel. And the logic behind it is just brilliantly simple. It's binary. It's as simple as this. If a needle in the loom finds a hole, it goes through, and that lifts its thread up. If it hits a blank spot, it's blocked, and the thread stays down. Lift or don't lift. That's it. A 1 or a 0. This is literally the physical embodiment of binary code, decades and decades before the first electronic computer was even a dream. Okay, so we have the software, the punched cards. Now let's talk about the hardware. How does the machine actually take those little holes and translate them into a woven pattern? All right, so this diagram shows you all the key parts of what they called the Jacquard head. This whole mechanism sat right on top of a standard loom. You can see the cylinder that holds the card, the horizontal needles that read it, these vertical hooks, and the knife bar that does all the heavy lifting. It's like this beautifully intricate mechanical dance. Let's walk through one cycle step by step. First, the cylinder turns and pushes a new card up against the needles. Now, any needle that finds a hole just stays put and its hook stays upright. But if a needle hits a blank spot on the card, it gets pushed back, and that moves its hook out of the way. And finally, this bar, it's called the griffaire. It rises up and it only catches the hooks that are still upright, lifting their threads. And boom, that creates the pattern for one single row. It's a purely mechanical if-then statement. If there's a hole, then lift the thread. So cool. Now, the concept was absolutely revolutionary, no doubt. But to really power the Industrial Revolution, it needed to be one thing: fast. The original design had a pretty big bottleneck, you see. Its heavy mechanism had to do a full up and down cycle for every single row that was woven. And here's the brilliant way they solved it. To run the loom at a good industrial speed, let's say 300 rows a minute, the original single lift machine needed its head to cycle 300 times. You can imagine the wear and tear on the machine. So the big innovation was something called the double lift system. It basically used 2 sets of lifting knives that worked in opposition to each other, and that cut the mechanism's workload clean in half. The loom still runs at the exact same speed, but the hardware on top only has to cycle 150 times. Genius! And that was the key. This wasn't some minor tweak. This single change turned the Jacquard loom into a true industrial powerhouse. We're talking less vibration, less maintenance, and suddenly the ability to produce these incredible fabrics on a scale that nobody had ever seen before. But honestly, the legacy of the Jacquard loom goes so much further than just textiles. By separating the instructions, the program, from the machine itself, it introduced a concept that would go on to define our entire future. Look, if you take away one single thing from all this, it should be this. It was the first machine to be truly programmable. You could make a completely different pattern just by swapping out the chain of cards, the software, without ever touching the hardware. And that right there, that is the fundamental principle behind all modern computing. I mean, you can draw a perfectly straight line from this loom right to the computer or phone you're watching this on. As you can see here, Charles Babbage, the father of the computer, he directly used punched cards for his analytical engine. Then Herman Hollerith used them to process the 1890 US Census, and his company? It eventually became IBM. For more than 150 years, the humble punched card was the main way we talk to our machine. It really makes you wonder, doesn't it? Back in 1804, people saw a machine that could weave amazing patterns. They probably just thought, wow, that's a better way to make fabric. They could never have imagined that its core idea, storing instructions separately from the machine, would one day lead to things like space travel or the internet. So it just begs the question, right? What are the punched cards of our time? What technologies are being invented today that are quietly laying the foundation for a future we can't even begin to predict?